Preparing for your data science interviews or AI or generative AI interviews, what is the most important segment one need to focus? The very simple answer is learning your machine learning algorithms, deep learning algorithms, and even generative AI algorithms gonna be an important element. The reason why is without understanding the theory behind your traditional ML or without understanding the theory behind deep learning algorithms or generative AI algorithms, one cannot develop any machine learning use case or AI use case or generative AI use case in the real-time job. So now based on our day-to-day job profile, so I listed down some most used or the important algorithms which we use it in our day-to-day life. So as a AI engineers and all that, so how exactly or which algorithms we use it. So this entire video focuses on the same thing. Now in case if you are new to my YouTube channel, please do subscribe to my YouTube channel, and apart from it, and in case while you're watching this video, if you are getting any questions or queries, please feel free to post it in the comment section. I can just help you to resolve those issues. And without any waste, let's get into our topic. Now, the machine learning algorithms can be categorized into three categories. Even if you want, you can categorize it into semi-supervised learning and reinforcement learning. Here I placed unsupervised, supervised, semi-supervised, and again if I want, I can place reinforcement learning. And after reinforcement learning, I can place even semi-supervised learning. So I'm not touching upon reinforcement learning and semi-supervised learning. I will be touching it on the later classes. And now when we are getting into your unsupervised way of learning, we know a bit idea. Unsupervised way of learning is called as, if there is no specific output, we are able to go with unsupervised learning. So what exactly meant by no specific output? Now if you are able to take your YouTube recommendations, so they are trying to give you the recommendations, but there is no specific output. What exactly meant by specific output is, now based on an image like cat or based on an image like dog, we are trying to say based on the image, I'm exactly saying, hey, it is a cat or it is a dog. We are giving the exact labeling. Now if I just show a scan of a patient, so based on the scan we can say, hey, this guy is having some issue with the health, or this guy doesn't have any issue with the health. We can say that there is a specific output. But if you take recommendations, there is nothing like a specific. Now I'm grouping the people based on location, or I'm grouping the people based on their interest, or I'm grouping the people based on their age group. All this falls into unsupervised way of learning, or we can say it as no specific output. So now I'm assuming you have some knowledge. So no specific output, we are able to call it as unsupervised way of learning. And while you're preparing for your data science or ML interviews, try to focus on, within unsupervised way of learning, you can prepare clustering based. You are able to prepare another one within after clustering, you got associate rules. So associate rule major purpose is if you are trying to build as a data scientist market basket analysis, or you want to identify consequent for a particular antecedent. Example is you are buying an iPhone, then what are the chances of buying a screen card, or what are the chances of buying an AirPods? All this can be estimated with the help of associate rules. And after that we have dimensionality reduction. So now by using dimensional reduction, if you're having thousands of columns, you are trying to take hardly 2 columns or 3 columns, or even 10 columns or 20 columns. We call them as principal components. Now we call it as, or principal components is one of the algorithm which is used under dimensionality reduction. Now within clustering, again you have 3 types of clustering. So you got your regular k-means clustering. And another one, apart from k-means clustering, the second one you got is your hierarchical clustering, and the next one you got is your DB scan. Now when you are going with your k-means clustering, you are estimating, basically the theory wise, you are estimating your data is in a spherical format, or the clusters are in a spherical format. And when you are going with a hierarchical clustering, you are estimating you are having a hierarchical relationship. Mostly we use it for network analysis, or we can use it for your like text based analysis, like cluster dendrograms and all that, we can do it. And if you assume your data is not in a spherical shape, then you will be going with your DB scan. So I'm not going into the theory, so focusing on clustering algorithms. And with every algorithm, so try to prepare this elements. So pros and cons behind the algorithm, and apart from pros and cons, learn about assumptions and theory. In case if there is an assumption, try to learn assumptions and even try to prepare theory behind every algorithm. And after that, within associate rules, you are trying to develop this associate rules with the help of a priori algorithm. And after that, if you are going with dimensionality reduction, you can do dimensional reduction with the help of PCA, principal component analysis. Again, within PCA, you have theory like creating a standardized matrix, and then you are creating a covariance matrix. From there, you are creating eigenvalues, eigenvectors. You are taking your eigenvector and you are multiplying that with your standardized. In this way, you have the theory, principal component analysis. And again, you have another famous one, TSNE. And if you are going with your text data, in order to reduce, so you have a bag of word representation, to make it into the lesser size, we got an approach called as LDA. So by using given LDA, you are able to create topic modeling. Now, that is machine learning based dimensional reduction. If you are going into the deep learning side, then you have another one called as autoencoders. Autoencoders also can be used as a dimensionality reduction technique, but what is autoencoders, we will be discussing. Now, in lines of your clustering, you are preparing k-means, hierarchical, DB scan, and in lines of associate rules, you are learning a priori algorithm. Again, within each algorithm, you are learning about why that algorithm, why not, and assumptions behind it if there are, and you are learning about theory within that algorithm. And once you learned this particular unsupervised way of learning, then you need to get into your supervisor learning. So within supervisor learning can be categorized into two categories. One is regression algorithms, another one is a classification algorithm. And if you are able to take regression algorithms are used when your output is when output or your y parameter is continuous. When output is continuous, we will be using regression. Example, I am trying to predict what gonna be the salary, or I am trying to predict what going to be his pay scale, or I am trying to predict what going to be the price of the house, or I am trying to predict what going to be his diabetic levels, or what going to be his heart rate, or what gonna be his loan amount he is able to get it. So these are called as continuous data. Now if you are trying to estimate a continuous data, then you go with regression algorithms like linear regression. You are trying to learn, you can learn decision tree regressor. You can learn decision regressor. You can learn random forest regressor. You can learn SVM regressor. You can learn again gradient boosting regressor. In this way, you have different categories of your regression models. Now, what differs between a regression model and a classification model also you need to learn. So, what exactly differs between a regression model and a classification model? In simple, difference between regression and classification. In simple, the regression and classification changes in lines of loss function. So now what exactly meant by a loss function is the y actual minus y predicted is called as loss function. Y actual minus y predicted, we are able to call it as your loss function. Now, if I'm trying to build a regression model, I need to use one type of loss functions like mean squared error, mean absolute error, root mean squared error, or mean absolute percentage error. In this way, we are using this kind of functions. If you are trying to go with classification models, you need to use cross entropy, mostly cross entropy, hinge loss. So this kind of loss functions you are using. In classification, your loss functions contain probabilities. In your regression algorithms, your loss functions doesn't contain probabilities. They are simple y actual minus y predicted. And the reason behind why your means like regression based loss functions are ranging from simple y actual minus y predicted, why not probabilities is your regression models are ranging between minus infinite to plus infinite. If I take your output parameter, it can range between minus infinite to plus infinite. But if you are taking your classification, your output ranges between 0 to 1. That's the difference. So that's the reason we are going with the loss function going to be different. And apart from the loss function, if you are going with your this one means like the difference between regression and a classification is in a regression models, we no need to do encoding for your output parameter. No need of output encoding. So the output parameter no need to be encoded. If you take any sklearn library, scikit-learn library, you no need to encode it if you take any regression model. Even for a classification also, most of the people don't encode it. But apart from classification, if you are going actually into deep learning and all that, we need to encode it. Basically, sklearn internally encodes both the number of output parameters. For example, there are 4 classes, cat, dog, something like donkey, some extra animal, something like that. So it's going to encode them one how to encode them into 4 categories. Internally, sklearn going to do that, but if you are doing it with PyTorch, or if you are trying to do it with TensorFlow, even you want to encode them manually with your coding. So no need of output encoding. So for regression, but for classification you need to do it. So for classification you need to do that. And apart from it, if you're again going back to your deep learning versus machine learning, another one is your activation function at output layer for classification models, and no activation function at output layer for regression models. So if you are going with your regression models, there is no activation function. So in simple, if you take any neural network, if I'm doing a classification, I add a softmax activation if there are more than 2 classes. If it is for example, 2 classes, I can use a sigmoid activation. Now, but for your regression models, we don't use any activation function. The data need to range between -infinite to +infinite. For that, we no need to add any activation. These are the simple differences between your regression and a classification. The loss function wise, there is a difference because of the range of output parameter, and you no need to encode your output parameter for a regression model, but you need to encode the output parameters for a classification if it is deep learning. And if you are going with again deep learning, your activation function need to be added at an output layer like a softmax or a sigmoid, but for your regression you no need to add any softmax or your softmax or sigmoid. You don't need to add it for your regression models. That is the difference. And when you're going back to your classification, again, when to go with classification? When output is discrete. When your output is discrete, you are able to go with your classification models. So example, logistic regression. So logistic and linear both are same. So that if you are applying a sigmoid transformation to your linear, we are able to call it as logistic regression in simple. Now you got logistic regression. So it is a classification model, but it's not a regression model. So decision tree classifier, random forest classifier, gradient boosting, and again within gradient you have types, gradient boosting classifier, and then you can learn about SVM classifier, and again within SVM also you have hyperparameters and all that, and you can learn about KNN classifier. The same KNN is there in your regression as well. You got Nye-Bayes classifier. Now in this way you can select between. So now this theory you need to learn. At least these algorithms are important to prepare your theory. Now when you go back to your theory, now for every algorithm, if you take linear regression example, within linear you have assumptions. You got your types of regression like rigid regression, lasso, polynomial. You got types of regression, and you need to learn about the math behind your regression, like how we are calculating the coefficients and intercepts in multiple linear or in a simple linear. So how we are doing it in polynomial. So you need to learn the math behind that approaches, means how OLS works, how gradient descent works, how straight line works. That theory you need to prepare, and how assumptions are working, how assumptions are impacting your model performance. In the similarly, you are working on your classification algorithms. Every algorithm you are learning about pros, cons, so your math behind it and everything you are learning it. And apart from it, in the coding implementation wise, so try to prepare even the hyperparameter tuning. For example, if you take logistic, you cannot do a pretty much a heavy level of hyperparameter tuning. You are unable to do it. Now hyperparameter tuning is nothing but the way you are customizing the behavior of your model can be tuned with the help of hyperparameters. Now if you take logistic, you have a less amount of hyperparameters. If you go back to your decision tree, random forest, gradient boosting, you got a pretty much a wide range of hyperparameters. You can tweak them. By tweaking them, you are able to get a better performance, better learning we are able to achieve. We can control overfitting, we can control underfitting with the help of this hyperparameter tuning. So try to focus on even that hyperparameter tuning techniques. Now when you are trying to explain to the interviewer, so what are the best algorithms you tried it, and how you decided, for example you tried with all this, for example 6 or 7 algorithms, how you decided these are the 6 best algorithms, and out of the 6 how you decided this is the best algorithm for your particular project. So in this way you need to explain your thought process behind how you navigated from list of algorithms to one algorithm, or one or two algorithms, you want to share your approach. That is very, very important. For that, you are using your theory, your math skills and all that, you are trying to demonstrate it. So within supervised, you are trying to go to your regression models, classification models, and the same. Now these algorithms are from your traditional machine learning. Now if I'm going with the same supervised, I can develop it with the help of another algorithm called as deep learning. Now this entire machine learning is having a fixed mathematical equation. For linear, there is one mathematical equation. For decision tree, one mathematical equation, you have it. But no, I want to build regression or a classification with a concept of artificial neurons, which are available in our brain, the similar to the neural structure in our brain. If I want to develop a algorithm which can learn it with the help of artificial neurons, then I knock the door of deep learning. So with deep learning, by customizing the techniques like changing your activation, changing your loss functions, changing your encoding your output parameter, you are able to develop both regression models and classification models in deep learning. If I want to apply to a standard tabular data, for example, if I want to apply to a tabular data, I can use feed-forward neural networks. If you are trying to build any of this feed-forward neural networks, if you want to learn, you need to learn again 4 building blocks. You need to learn about list of activation functions. You want to learn about model architecture. You want to learn about optimizers. You want to learn about loss functions. You want to learn about batch size. You want to learn about learning rate. You want to learn about iterations or epoch. So these are the elements which you need to learn. And again, if you study about optimizers, you are learning about back propagation. So back propagation uses your gradient. So now you need to learn about back propagation. Now if you learn feed forwards, if you understand feed forwards very well, so implementing feed forwards, you can do it with scikit-learn, but we call MLP, multi-layer perceptron. That's not that great. The reason you are going to deep learning is ML and deep learning difference, if I want to give it. ML is more like an apartment. You cannot do a lot of customization. Only customization is changing the lights or changing the paint, hyperparameter tuning. Deep learning is more like constructing your home from the scratch. So you can change the way you are designing an architecture, the algorithm wise. Activations you can change, optimizers you can change, loss you can change. So you have a complete control over your algorithm, over every step in your deep learning. So if you want to build deep learning algorithms, it's better to have a knowledge on PyTorch or mostly PyTorch, or you can have a knowledge on TensorFlow. These two libraries are very important in order to implement deep learning algorithms. So tabular data, if you want to implement, I implement feed-forward neural networks. If I have an image data, then I will be going and implementing with the help of an algorithm called as convolution neural network. So now I'll be working on convolution neural network using same TensorFlow or PyTorch. So again, if I want to build a text-based data or a sequential data, again, this is called as classification or regression, you can do it. Now if you are having a sequential data, you are able to build it with RNNs, recurrent neural networks, or LSTMs, long short-term memory cells. Now in this way, by using deep learning, again we have various varieties of deep learning models, but most used feed-forwards, convolutions, RNNs, LSTMs, we use widely across every project. If it is image convolution, if it is audio or text data, sequential data, especially tabular sequential data, I can use RNNs or LSTMs. And after that, we got self-supervisor learning. What is self-supervisor learning? If you are able to give one part of the data, and if you can generate another part of the data, we call it as self-supervisor learning. If you give one part of the data, and if you are trying to generate another part of the data, we call it as self-supervisor learning. As part of it, we got our very first concept called as, if your data is time-based, or we can say time series data, means I'm giving one part of my time series data, it can start generating another part of the time series data. So to do that, we are going with an approach called as forecasting. So data scientists must learn this concept called forecasting. So we use ARIMA technique, or we use SARIMA. We use exponential smoothing. Or I can use again LSTMs, or I can use FB Profit, or I can use deep AR. deep AR. In this way, we have various approaches. By using them also, I can work on time series data, means I can pass again, or I can do forecasting with the help of LSTMs or RNNs. I can do this with the help of time series data. No, my data is image. So if I'm giving an image data, I want to generate an image. For example, image based Gen AI. If I want to do image based Gen AI, I can start doing with the help of autoencoders. Within the autoencoders, you have the type like denoising autoencoders, variational autoencoders. They are used if you are having a blurred image to make it into HD image, or if you want to create various varieties of shoes. Example, I can use variational autoencoders, or I can start developing this image-based generative AI with the help of GANs, generative adversarial networks. So by using generative adversarial networks, also you are able to start developing image-based generative AI, or you can start developing it with the help of diffusion models. With the help of diffusion models, you can start developing image-based generative AI. And apart from it, you can use various architecture like CLIP architecture, DALI-E2 architecture, Glide architecture. We have various other algorithms. Even by using that also, you can start developing it. And now, as a beginner level or as an 1 or 2 year level, I think these are the most widely used algorithms at an job. And no, means while you are working in a company, people may not start developing an algorithm from scratch. They try to leverage this GAN model which is already there, diffusion model which is already there. We are calling that approach as pre-training. Now I try to take a pre-training algorithm which is available in Hugging Face, or which is available in TF Hub, or which is available in Torch Hub, etc. I take that pre-trained models, I can customize it with my company requirement, I can call it as pre-training. Now to do that pre-training, you need to have a knowledge on transfer learning especially, and you need to know about how you can improve the model accuracy with the help of transfer learning, so that you are learning about libraries like Hugging Face. Especially Hugging Face is very important if you are dealing with like pre-trained models. Hugging Face is very, very important. Try to leverage that. Learn about how to improve the performance with the help of transfer learning. That's very good. And after image-based generative AI, then you need to learn about text-based generative AI. So within text-based generative AI, if you want to learn an advanced theory, then you need to learn from encoder-decoder models. You need to learn about attention-based models. You need to learn about transformers. Again, within transformers, you can develop BERT model, you can develop GPT model, you can develop T5 model. And after developing T5 model, you need to start using these models. How you can start using these models? With the help of, again, you can use it from pre-trained models, you can take it from Hugging Face, or if you want a heavy model, you can start using them with the help of, so how to use them? How to use them? If I want to develop them, for example, if I want to use them, then I can use it with Hugging Face, pre-trained models, or I can take them with the help of API from Meta, or I can take it from Amazon Bedrock, or I can take it from OpenAI. I can take an API key. With the help of API key as well, I can start leveraging those models. But these models are developed on internet data, or which is available. Now I want to customize them. So how to customize these models? How to customize these models? I can customize these models using prompt engineering. I can customize them using RAG. I can customize them with fine tuning. I can customize them with pre-training. Now in this way, you are able to focus on, so now if you are trying to learn about your, means like some specific algorithm, hey, I want to be an AI engineer, so get up to self-supervisor learning. No, I want to be a data scientist, so try to learn your unsupervised learnings, and try to learn your supervised algorithms. And in case if you are good with it, so if you are having some good time, so try to learn even deep learning algorithms like feed forwards, computer vision, or convolution neural networks, LSTMs, RNNs, and learn up to time series. So this syllabus is sufficient to be a data scientist. I want to go beyond that. I want to learn even AI roles and all that. Then try to learn your image-based generative AI and text-based generative AI. This is means like I'm not targeting like you want to be a pro at everything, but this syllabus is a decent syllabus, and if you are able to work on couple of projects across text-based Gen AI, couple of projects on image-based Gen AI, time series, you are able to secure a job and you can clearly crack your interviews. But every theory, the concept is be very thorough with the theory. Coding, anyone can do it. So now even a ChatGPT can write a code for all this. But what differentiates you from other people is that reasoning. So now ChatGPT can reason it based on available theory, but your reasoning is different. The reason is you are applying them in your job based on that you are listening to the business, based on that you are selecting and right algorithm. Now companies going to hire you for that knowledge, for that architectural knowledge you have it, when to select ML, when to select deep learning, when to select pre-training, when to select developing an algorithm from scratch. If I want to develop from scratch, what need to be the tech stack. So all this is going to help you, means like this is something what companies are paying for you and they are hiring you. So if you are preparing, try to prepare in these lines, and any doubts you can just share it in the comment section. I hope you got a clear understanding about all the topics which we discussed right now. Thank you so much.